Cool. So, good morning. Welcome back. I hope the rest of your day went well yesterday. And that this morning is started off all right for you. I do recommend that you have notes from yesterday available and that you have some scratch paper to work with today and something to write with on that scratch paper to help with the Desmos activity we're going to do. Because you're going to want to be able to use some of these formulas and do some work here to solve some of these problems. So yes, today we are doing our practice activity for section 8.2 on estimating population proportion. I'm going to put that link to the Desmos activity into the chat. There we go. You can also go to student.desmos.com and find the 8.2 activity in the course that we have set up in Desmos, or the class we have set up in Desmos. Those are the two options. All right, everybody, we're going to get started. I see that there's a couple of students who still have not joined the activity. Please do so in the next couple of minutes so that you can participate and get the opportunity for the amazing learning that's going to take place today about estimating population proportion. Right, so next, we're going to open this up. If you're still answering that first check-in question, please feel free to continue completing that response. I'm going to add the next screen here. And this is just a review of some main things that we should have taken away from yesterday's lesson. I do realize these images come up rather small. I do not know how to make Desmos make these images larger yet. I'm working on figuring that out. So they're a little bit small, but you should have these things in your notes, hopefully, or you can access them through the copy of the notes in Canvas. So we have our conditions for constructing a confidence interval, random 10% and large counts. Our 4-step process for confidence intervals, right? State, plan, do, conclude. Those 4 steps are important. We should do them every time we do a confidence interval. A 1 sample Z interval for population proportion is our inference method that we learned yesterday. That allows us to create the confidence interval. And we have the sample size for a desired margin of error inequality that we will use to determine a sample size that will result in a specific percentage of confidence with a certain margin of error. Right? So these are some key things that we should have taken away from yesterday's lesson. So they're reviewed here. You may need to navigate back to this screen to look back at these formulas, and that is okay. I'm going to leave this screen available throughout the lesson. And today I'm just going to be like adding the screens as we move through. So you'll be able to kind of move back and forth between all of the things we've done throughout the day. So with that, we're going to do the first 2 problems. The first 4 problems are actually all multiple choice problems. 3 of those 4 you're going to have to do calculations and use some of these formulas in order to solve them. You could guess, that is always an option in multiple choice. But to get the correct answer, you're going to need to do some work. You're going to want that scratch paper. You're going to want to use these formulas. All right. So I'm going to go ahead and open the next 2 screens. And if you guys are following along in the shared screen, I'm kind of modeling these things here as well. So you can look on your own Desmos screen, or you can look at the shared screen to see what I'm talking about exactly. That's up to you. Please do notice that on each of the screens, you have these 2 buttons on the top. One opens up a calculator for you. So if you don't have your calculator handy, you have a little calculator that'll pop up here that you can use. So there's that. And this just makes it go full screen, but I don't know that it doesn't change how big things are. So there's that. So anyway, here's our first multiple choice question. We have a Gallup poll found that 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error was plus or minus 3 percentage points at a 95% confidence level. This means that, and you need to select the correct statement that completes that sentence. What's the meaning of the data, the information just provided? Only one of these statements is correct. The second multiple choice question will involve using some calculations. Most people can roll their tongues, but many can't. The ability to roll the tongue is genetically determined. Suppose we are interested in determining what proportion of students can roll their tongues. We test an SRS of 400 students and find that 317 can roll their tongues. The margin of error for a 95% confidence interval for the true proportion of tongue rollers among students is closest to one of these 5 numbers. All right, so you will need to use, we're going to need to figure out the margin of error, right? So you're going to need to use one of these formulas to determine our margin of error based on the provided data. All right, let's talk about these 2 questions. All right, so if you'd like to follow along with what I'm talking about, I would suggest going to this shared screen in Teams. So you can see what I'm talking about. So we're going to look at the multiple choice 1 first. The Gallup poll. The correct answer was that the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. All right. This is because this context is referring to our confidence level, right? And remember, when we're interpreting confidence interval and confidence level, they have a slightly different interpretation. The confidence level says that if I repeat this sampling over and over and over again, that the resulting intervals from my samples will capture the true parameter, whatever percentage amount of the time. Right, and so our margin of error was plus or minus 3 percentage points at a 95% confidence level, meaning that those intervals from, if I repeated this sampling many times in this method many times, that I'll get within 3% of the true proportion 95% of the time. Okay, so that is multiple choice number 1. Is there anything I can clarify about this problem or this question as to why the other ones are not correct and this one is? Okay. All right, so then we're going to move to multiple choice 2, right, the 4th screen. And again, with the rolling of the tongues, all right, the margin of error for a 95% confidence interval for the true proportion of tongue rollers among the students is closest to 0.04. And to see why this is a solution, we're going to look at the work. So if we look at kind of the scratch work here for this problem, we start with a p-hat of 317 out of 400, or 0.7925. This is the proportion of people who can roll their tongues from our sample of 400. We have a sample size of 400, and the z-star, the critical value for a 95% confidence interval, is 1.96. We can find this on table A, or if we recall from our results yesterday, we use this several times. So then we use the formula that the margin of error is equal to z-star times the square root of p-hat times 1 minus p-hat over n, right? Critical value times standard error. We replace all the numbers with our variables, and we get 1.96 times the square root of 0.7925 times 0.2075 divided by 400. We get approximately 0.036, meaning that our closest approximation of the available numbers is 0.04. Right? We're closer to 0.04 than we are to 0.03. Okay. Remember, the margin of error is the part of our interval calculation. It's the number we're adding or subtracting to our statistic, right? And that is our critical value times standard error, or critical value times standard deviation, right? Is there anything I can clarify about this calculation and how we got the results we did for multiple choice 2? All right. So then we're going to move to the next 2 multiple choice questions. All right. The multiple choice 3 question. You want to design a study to estimate the proportion of students at your school who agree with the statement, the student government is an effective organization for expressing the needs of students to the administration. You will use a 95% confidence interval, and you would like the margin of error to be 0.05 or less. What is the minimum sample size required? So in this particular problem, you'll be needing to solve this inequality based on the provided context. Right, the sample size for a desired margin of error over here on screen 2. Right. Multiple choice 4. A newspaper reporter asked an SRS of 100 residents in a large city for their opinion on the mayor's job performance. Using the results from the sample, the C% confidence interval for the proportion of all residents in the city who approve the mayor's job performance is 0.565 to 0.695. What is the value of C? So in this scenario, we're working backwards from a known interval to determine what was the percent confidence interval that we were dealing with. All right, so we have the interval. We have to use that information to work backwards to p hat, right? We can then use that to work backwards to a critical value. From the critical value, we can use table A to get back to like the proportion. Okay, so this one's going to take a few steps. All right, multiple choice 3. All right, the minimum sample size required is 385 students. All right, and we get that with this work right here. Okay, so again, I suggest that you switch over to the shared screen so you can see the work that I'm referring to. We start with the known information that we don't have a p hat, so we're going to use the guess of p hat equaling 0.5. Remember, when we're estimating a sample size that we need, right, we either can use a proportion from a previous like smaller sample or previous study, or if we don't really have an idea, we have to use the guess of 0.5. So that's what we're going to do in this scenario. The margin of error we're looking for is 0.05. We're looking for a 95% confidence interval, which means we have a Z star, or critical value of 1.96. We're using the formula that we have the critical value times the standard error is less than or equal to the margin of error. We're going to rewrite this. Right? I'm going to rearrange this formula, which you do not have to do. You may want to just keep it the way it looks and solve for n. That's fine. I'm choosing the route of rearranging the formula first and then putting it on my values. So we get n is greater than or equal to the critical value times the square root of p hat times 1 minus p hat divided by the margin of error, all squared. I replace all my numbers, and I get n is greater than or equal to 1.96 times square root of 0.5 times 0.5 divided by 0.05 squared, and we get 384.16. Because n must be greater than or equal to 384.16, I need to round up. I cannot round down to 384. I go to 385. So our minimum sample size is 385 people. Is there anything I can clarify about the work here and how we got 385, or how I got 385? Multiple choice 4. All right. The correct value of C is 82. All right, so the confidence interval we found from 0.565 to 0.695 is the 82% confidence interval. All right, and here we go. We have the work for this one. We're right here. Once again, I'm starting my work here by listing what I have, right, and what I'm looking for. I have a C% confidence interval that I have the interval 0.565 to 0.695. I have a sample size of 100. I do not know what the critical value Z star is. I can start by finding the sample proportion, P hat. And I can find this because the sample proportion is the midpoint of my interval. So I take the two endpoints, 0.565 and 0.695, divide them by 2. I get 1.26 over 2, I get 0.063. So that means P hat is 0.63. Right? We know that we get a confidence interval by taking our statistic, P hat, adding and subtracting the critical value times the standard deviation of the statistic, otherwise known as the standard error. I know what the margin of error is because I know what P hat is and I know what the endpoints are. So I can calculate the margin of error by subtracting the lower endpoint, 0.565, from P hat. Right, and that gets me 0.065. Now that I know the margin of error, I can calculate the critical value. Right, and we use the formula margin of error equals critical value times standard error. Right, we get 0.065 equals Z star times the square root of 0.63 times 0.37 divided by 100. We divide each side by the standard error, the square root thing. We get Z star equals 0.065 divided by square root of 0.63 times 0.37 divided by 100. And we get approximately 1.35. We need to find negative 1.35 on table A. Right? This is our Z-score that we'll find on table A. And trace that to the interior of table A. And we get that the proportion is less than negative 1.35 on the standard normal curve is 0.0885. Pull up my table A. And of course, I don't have that one on here. Sorry, I was using this yesterday. And we see here, right, our negative 1.3, 0.05. Trace these down and over. And that's where we find our 0.0885. And that is the proportion on the left-hand tail of our normal curve. Because that's for only one tail, and I know that the proportion left out is split evenly between two tails, I double that number because I have two tails, and we get 0.177. We subtract the 0.177, the proportion of the normal curve that we're leaving out, from 1, and we get 0.823. So C is about 82, or an 82% confidence interval. And that's how we get that solution. Is there anything I can clarify about the work that goes with multiple choice 4? And this one involved a little bit of the connecting the dots kind of stuff. Alrighty. So we're going to move to the next slide here. Our 93% confidence question. Right, we need to find the critical value Z star for a 93% confidence interval using table A. Right, you have a little picture of table A here, and again, I apologize, I can't make it larger. I'm going to try and figure out how to do that on these slides, but the portion of table A you need is here. If you have a copy of table A that you would prefer to use, please feel free. You're going to sketch on the copy of table A showing the proportion to the left of the Z-score that corresponds with a 93% confidence interval. Remember, our 93% confidence interval captures the center 93% of our normal curve, leaving a proportion of that curve split evenly between the two tails. You need to determine what's left over, divide that number in half, find that percentage as a decimal in the interior of table A, and then trace it to the left-hand column for Z and the top row for Z to create your Z score. Remove the negative sign, and that becomes your Z star. All right, let's talk about this one. Looks like we got a few different answers going on. All right, so let's look at the work here. So the correct Z star, right, the correct value should be 1.81 from table A, right? Remember, when we're dealing with the critical value, Z star, we take it as a positive number, or think of it as like an absolute value. I'm interested in the distance and not necessarily whether or not it's positive or negative, because I'm almost always going to be looking for this value using the negative side of table A. All right, so we're going to take it as a positive number, right? Z star is going to be positive, and then we use it that way because we're going to take that critical value and multiply it by the standard error, and then that number is going to be added and subtracted to p hat. Right? So technically we could keep it negative as well, and we'd get the exact same results, right? If we use negative 1.81 in our calculation, but our margin of error would then be calculated as a negative number, and that is not correct. The margin of error is a positive number. Okay, so let's look at the work here. So we take 1 and we subtract 0.93 to get the leftover proportion of our curve that is not part of our confidence interval, 0.07. We then take 0.07 and divide it by 2, we get 0.035. The closest value we have on table A to 0.035 is 0.0351. We trace that to the left to negative 1.8 and up to the top 0.01, and we get a Z value of negative 1.81, which gives us a critical value of 1.81. Right? So we're using table A on this one. Is there anything I can clarify about this example? Okay. All right. So with that, I'm going to stop sharing my screen here. We're going to stop here. There are 3 more questions available on this Desmos activity, and you're welcome to do them. I will remove the screen restrictions here in just a moment. But we're going to stop here as a class today. And I do want to encourage you to continue practicing, whether you do the Desmos problems or you do the practice problems that are available in Canvas in the resources for section 8.2 and 8.3. Those practice problems and their solutions are available now in the course. Those are excellent opportunities to practice this content. There's also a bunch of AP Daily videos linked in the resources as well. I think there's like 3 or 4 videos that apply to estimating population proportion, and there's like 3 or 4 that have to deal with estimating population mean, which we'll do next week. So there's lots of resources available for this, and there's worked examples from the textbook as well. So please keep those resources in mind, use those to review and to get a better understanding. Yeah, as usual, if you do have any questions, you want some extra help or support, feel free to stick around after the class, and I will be happy to answer any and all questions. I also do have my office hours on Monday from 12:15 to 1:15. If you want to stop by for that, you can get questions answered there. Other than that, that is all that we have for today. Remember, on Monday, you will now be going to your third period class for the T lessons, because we will be in March starting Monday. And for the month of March, all your T lessons are in period 3. So I will not see you on Monday, but I will see you on Thursday and Friday next week. All right, so enjoy the rest of your Friday. Have a great weekend, and I will see you next week.